Hello friends. In previous lecture, we discussed about the fluid properties and the last properties, that is the bulk modulus and compressibility. So consider a piston cylinder arrangement, and this is the initial position of the piston and the initial pressure, that is P, and initial volume, that is V. Okay, now if you apply some extra pressure, then the final pressure, that is the P plus dP, and the final piston position, that is this position, this is the final position. And what is the final volume? That is dVf, that is equal to V minus dV. dV is the change in volume. So here this volume is the dV. Okay, now so in that case, if you calculate the volumetric strain epsilon V, that is equal to del V by V. Okay, so del V is the change in volume by original volume. So epsilon V, that is equal to V final minus V initial by V initial, that is equal to V minus dV by V minus V by V. So from here epsilon V, that is equal to minus of dV by V. Now dP is proportional to epsilon V. So change in pressure, that is proportional to volumetric strain. So there is a proportionality constant K will come into the picture. So here K, that is equal to dP by epsilon V. So K is the bulk modulus. So from here K equal to dP by, what is the value of epsilon V? That is this value. So epsilon, this is the epsilon V. So this is the volumetric strain value. So minus of dV by V. So that is equal to, you can write in that way, dV by d rho by rho, that is and this formula is applicable for liquid and gases. Okay, so how minus dV by V equal to d rho by rho, we will see that. So we know that rho equal to m by V. So from here rho into V, that is equal to m, and if m equal to constant in that piston cylinder arrangement, so rho V, that is equal to m. So ln rho plus ln V, that is equal to ln m. So d rho by rho plus dV by V, that is equal to 0. So from here minus of dV by V, that is equal to d rho by rho. So this minus of dV by V is equal to d rho by rho. So this is formula. So this formula is very important for to solve problem. Okay, so now now so if the incompressible fluid, so for incompressible fluid, for incompressible fluid, for incompressible fluid, for incompressible fluid, if dP is greater than 0, dP is greater than 0, dP is greater than 0, then K, that is bulk modulus, tends to infinity. Okay, so we know that the K, that is equal to dP by epsilon V. So here if K equal to infinity, so what is the value of beta? So we know that beta, that is equal to 1 by K. So if this is infinity, K is infinity, 1 by infinity, so this will be 0. So for incompressible fluid, the compressibility, that is equal to 0. So for incompressible fluid, the compressibility that is equal to 0. So very important concept. Now compressibility, we know that is compressibility, that is beta that is equal to 1 by bulk modulus. Okay, so from here beta that is 1 by, what is the bulk modulus, that is dp by epsilon v. So this is dp by epsilon v. So from here this is epsilon v by dp. Okay, so from here that is minus dv by v by dp. Okay, so that is equal to d rho by dp. So from here beta that is equal to 1 by rho d rho by dp. So this is very important formula. Okay, so beta that is equal to 1 by rho d rho by dp. Okay, and k, we know that formula, that is rho into dp by d rho. Okay, this is also important formula. Remember this formula, very important. Now so if we draw the PV diagram of that piston cylinder arrangement which we discuss in here, so now draw the PV diagram for that piston cylinder arrangement. So here this is the P and this is the V axis, that is pressure, this is volume. So the process will be like this. So this is process, this is state 1, this is state 2, 1 to 2 process, and just dotted line is there, so there is also dotted line. Okay, so this is the initial pressure, this is the initial pressure. So P is our initial pressure, and this is the final pressure, that is P plus dp. So our final pressure P plus dp. Okay, so this is our final pressure. And what is our initial volume? Initial volume is V. Initial volume, this is the initial volume, that is V. And what is the final volume? So here this is our final volume, that is V minus dV. So actually this is this distance. So here to here the distance is minus of dV. Okay, and here to here, so this is dP. Okay, so this is the slope. Okay, so here this is the slope. Okay, now if we calculate the slope that is equal, that is theta, that is equal to dP by minus dV. Okay, so this is the dP by minus dV. Okay, so we know that is K, that is equal to dP by minus dV by V. So from here K, that is equal to V dP by minus dV. Important. So from here we can say that K, that is proportional to minus of dP by dV. Important case. So K, that is proportional to, that is the, what is minus dP by dV? That is the slope. That is the slope. That is K proportional to slope of PV curve. Important. So K proportional to slope of PV curve. Okay, now if we draw the PV diagram again, so this is our P and this is V. Okay, so this is our slope. So if you can here the slope, that is theta 1, if the slope here, that is theta 2, and this is theta 3. So here theta 3, so this theta 3 is greater than theta 2, greater than theta 1. So theta 3 is greater than theta 2 is greater than theta 1. So if pressure increases, so if the pressure increases, then the theta, if the pressure increases, then the theta that is slope is also increases, and if the slope is increases, then k also that is bulk modulus also increases, and if k increases, that is inversely proportional to compressibility, so beta will be decreases. So this is the relation between pressure, slope, compressibility and bulk modulus. Important case, remember. Okay, now there are one notes are there. So what is the key notes? Remember this notes. That is, as pressure increases, the opposition for further compression increases. So the bulk modulus increases. So bulk modulus is not constant property. So here this bulk modulus is not constant property. Okay, now ability of compressor under pressure is known as compressibility. Okay, ability of compression under pressure is known as compressibility. Now, if there is no change of density with pressure, then the fluid is said to be incompressible. If there is no change of density with pressure, then the fluid is said to be incompressible. The fluid is said to be incompressible. Okay, so important notes. Okay, Now there are one problem. So there are one question is there. So the question will be like this: the equation of a state for a liquid is P equal to 3500 rho to the power 1 by 2 plus 2500 Newton by meter square. The bulk modulus of liquid at a pressure of 100 kilopascal. So what is given in this question? So P, that is equal to 3500 rho to the power 1 by 2 plus 2500. What is the unit of that? That is Newton per meter square. Okay, and you have to calculate the bulk modulus of liquid at pressure. What is the pressure is given? The pressure given as 100 kilopascal. So pressure, that is 100 kilopascal. Okay, so you have to calculate the bulk modulus. So what is the you have to calculate the bulk modulus K. Okay, what is the formula of bulk modulus K? That is equal to, what is the formula? That is rho into dP by d rho. Okay, important case. Now just we needed, that is dP by d rho. So we know that P, so here P equal to 3500 rho to the power 1 by 2 plus 2500. So what is dP by d rho? That is equal to half into 3500 rho to the power minus half. Okay, n into x to the n minus 1. Okay, so this is the case. So from here you can calculate that dP by d rho, that is equal to 1750. This is divided by 2. So 1750 divided by rho to the power half. Okay, and what is the value of rho? What is the value of rho? So dP by d rho. Okay, now okay, now put the value here. So rho into, what is the value of dP by d rho? That is 1750 divided by rho to the power half. So from here 1750 into rho to the power half. Okay, now so we know that P equal to 3500 rho to the power half plus 2500. So from here 3500 rho to the power half, that is equal to P minus 2500. Okay, so from here rho to the power half, that is equal to P minus 2500 by 3500. So just put the value here. So 1750 into P minus 2500 by 3500. So from here 1750 into, what is the value of P? That is 100 kilopascal. So 100 into 10 to the power 3, because it is a kilopascal. So 10 to the power 3 multiplied that. So 2500 divided by, that is 3500. So if you calculate this value will be 48750 Newton per meter square. Okay, Newton per meter square. So this will be our answer. Okay, this will be our answer. So the unit is Newton per meter square for bulk modulus. Okay, now there are another concept is that bulk modulus of gases. There are two types of bulk modulus is there. So we know that formula, that is K equal to rho into dP by d rho. Okay, but for gases there is two type of bulk modulus. One is isothermal bulk modulus and adiabatic bulk modulus. So our next concept is that that is bulk modulus of gases. Bulk modulus of gases. Okay, important concept. So there are two types of bulk modulus. So here there are two types of bulk modulus. So one is isothermal bulk modulus, isothermal bulk modulus, and second one, that is the isentropic or adiabatic bulk modulus. Isentropic process is also known as adiabatic process. So isentropic or adiabatic bulk modulus. Okay, so these two types of bulk modulus, that is very, very important. So for gases there are two type of bulk modulus. One is isothermal, that is temperature that is equal to constant. So isothermal, where temperature that is equal to constant. Okay, and one is adiabatic bulk modulus, where PV to the power gamma that is equal to constant. We know that from thermodynamics. Okay, now so for isothermal cases we know that ideal gas equation PV that is equal to mRT. So this is the ideal gas equation. This is the ideal gas equation. Okay, so from here P equal to m by V, that is rho RT. Okay, so from here dP by d rho, if you calculate, that is equal to R into T. Okay, so if you multiply rho in both sides, rho into dP by d rho, that is equal to rho RT. So rho into dP by d rho, that is, what is the rho RT? That is P. So this is P. So rho into dP by d rho, what is that? So what is that? Rho into dP by d rho, that is the compressibility K. Sorry, this is the bulk modulus K. So K, that is equal to P. Okay, so remember that this is very, very important for isothermal process. For isothermal case, the compressibility that is equal to pressure. Okay, and if you want to calculate the bulk modulus that is equal to 1 by K. So that is equal to 1 by P. Okay, so this is very, very important case. So beta that is equal to 1 by P. And if there is a state 1 and state 2, and if you want to calculate for state 1 and state 2, we can write P1 V1 that is equal to P2 V2. So from here P2 that is equal to P1 V1 by V2. Okay, so for that case, if you want to calculate the bulk modulus, that is equal to P2, and compressibility beta that is equal to 1 by P2. Okay, so this is all about the isothermal case. Okay, now for adiabatic case, so here this is the adiabatic case, that is PV to the power gamma that is equal to constant. So from here V equal to rho equal to m by V. We know that rho equal to m by V. So V equal to m by rho. So m by rho to the power gamma that is equal to constant. Okay, so here from here we can write that P by rho to the power gamma that is equal to constant. So from here P equal to C into rho to the power gamma. Okay. Now from here we can write dP by d rho, that is equal to gamma C rho to the power gamma minus 1. Okay. So multiply rho in both sides, rho into dP by d rho, that is equal to rho gamma C rho to the power gamma minus 1. So from here rho dP by d rho, that is equal to gamma C rho to the power gamma. So rho to the power gamma. So C rho to the power gamma, that is equal to P. So from here rho dP by d rho, that is gamma into P, because we know that P equal to C into rho to the power gamma. So rho into dP by d rho, that is equal to gamma into P. So if you want to calculate the compressibility, this is the bulk modulus K, that is gamma into P. Okay, so K, that is the formula K equal to rho into dP by d rho. So from here bulk modulus, that is equal to K into gamma into P, K equal to gamma into P. And if you want to calculate the compressibility beta, that is equal to 1 by K, that is equal to 1 by gamma into P. Okay, so this is the case here. Okay, now for process 1 to 2. Okay, so for adiabatic bulk modulus, if there is a process 1 and 2, so you can write P1 V1 to the power gamma, that is equal to P2 into V2 to the power gamma. So from here P2, that is equal to P1 V1 to the power gamma upon this is V2. Okay, so if you want to calculate the bulk modulus, that is equal to gamma into P2, and if you want to calculate the compressibility beta, that is equal to 1 by gamma into P2. So these are very, very important. Okay, so now there are one problem are there. So given, so there are one problem are there. A cylinder contains 0.35 meter cube of air at 276 kilonewton per meter square absolute pressure. The air is compressed to 0.071 meter cube. Assuming isothermal condition, you have to calculate the bulk modulus, and if the adiabatic bulk modulus of elasticity at new state, if the specific heat ratio gamma is given for air, that is 1.4. So what is given in this question? So the initial volume, that is the 0.35 meter cube. Okay, and the final volume, that is the 0.071 meter cube. Okay, and the absolute pressure, what is P1 is given, that is 276 kilonewton per meter square. So this is given. Okay, so you have to calculate the bulk modulus for isothermal case. So you have to calculate for temperature that is equal to constant, you have to calculate what is the value of bulk modulus. And second case, this is the second case. So if this is adiabatic process, gamma is given, gamma is equal to 1.4. So you have to calculate the value of bulk modulus. So focus on the case 1. So temperature that is equal to constant. So we know that ideal gas equation PV, that is equal to mRT. Okay, so for isothermal process, that is M is constant, R is constant, T is constant. So for isothermal process, T is constant, we can write P1 V1, that is equal to P2 V2. Okay, so from here, that is uh, p p2. If you want to calculate the p2 value, so p2 that is equal to p1 v1 by v2. Just put the value here. So what is the value of p1? P1 is 276 276 into v1. What is the value of v1? V1 that is 0.35 0.35 by what is the value of v2? 0.071. If you want to calculate the value of p2, that is the 1360.6 kilonewton per meter square. So here the p1 that is unit kilonewton per meter square, and here also the unit will be kilonewton per meter square. Okay, so this is the case. Now p2 is that. So we know that for isothermal cases, if you want to calculate the bulk modulus K, that is equal to p2, so that is equal to 1360.6 kilonewton per meter square. So if you want to transfer it in meganewton per meter square, so that the answer will be 1.36 meganewton per meter square. So this will be our answer for first case, for isothermal case. Now for adiabatic case, second. So adiabatic case, we know that p1 v1 to the power gamma, that is equal to p2 v2 to the power gamma. So from here p2 that is equal to p1 v1 to the power gamma by v2 to the power gamma. So from here, what is the value of p1? P1 that is equal to 276 into v1 to the power gamma, that is v1 to the power gamma, that is 1.4, divided by v2. What is the value of v2? That is 0.071 to the power gamma, 1.4. So if you want to calculate this value, that will be 2.575 meganewton per meter square. So what is the bulk modulus? So K, that is equal to gamma into P2, we know that. So gamma, that is 1.4 into P2, that is 2.575. What will be unit? That is meganewton per meter square. So if you want to calculate this value, that is 3.61 meganewton per meter square. So this will be our answer. So for isothermal cases, the answer will be 1.36 meganewton per meter square, and this is our answer, and here this is our answer for adiabatic cases. So this is all about the bulk modulus. So in next lecture we'll discuss about the sonic speed, Mach number, and we will discuss the viscosity and kinetic viscosity or momentum diffusivity. So in description you will find my handwritten notes are there. You can download it from the description. Okay, so if you have any doubt, any question, you can ask me in message, and there are one Telegram group, you can join that, and one WhatsApp group you can join to get latest update. Thank you.